diagram shows a cross section of a road tunnel. The tunnel is part of a circle of radius 5 meters. The width of the tunnel at road level is 9.6 meters. Calculate the height h. Okay. Now, for those of you who weren't really, it's in a circle, right? But it's not a full circle because it's cut off at the bottom. Everybody cool with that? So what we're thinking is that we'll do the radius first. The radius can be this green part here, and that's worth 5. Can everybody see that? We'll use yellow. You see it now? It's worth 5, okay? And what we're going to say next is that what we'd love to know is what is this pink distance here. Ever see the pink distance? Yeah. And combined they give the total height. So I'm going to do Protagonists Theorem, where 5 squared equals 5 squared. Now see that see that 9.6 at the bottom. That 9.6 at the bottom is going to get halved. It's going to get halved into 4.8 because from here to here is 4.8. So we're going 5 squared equals 4.8 squared. We'll call this I don't know, a plus a squared. Alright lads, what's 25 take away 4.8 squared? I'm just asking what 5 squared minus 4.8 squared is. 1.96. Square root that, I think a is 1.6. Then we get a equals 1.6. Oh sorry, 1.4. Sorry, I always get that mixed up. 1.4, my fault. You got 1.4? Alright, now that's not the answer to my question, because the total height has to be 1.4 plus your 5, which is 6.4. Okay. Now, the next thing is okay. I suppose what's saying is an extra wide vehicle, 6.8 meters wide and 4.5 meters high, wants to enter the tunnel. Would this vehicle be able to enter the tunnel? No. Well, I'm going to show you a quick. I'm going to do a quick diagram here, okay?
You actually yes, but no, not one that would actually say.
Yeah. I'm probably overcomplicating it. You know what I'm thinking? Which is probably. Oh. Sorry, just give me a sec. I choose the wrong colour. There it is. Where's clear? No fill. Where's no fill? Oh. Why do I do that? Line colour. Alright, grand. I'm thinking something like this, alright? Just to represent your vehicle, alright? What size would it be either side? So if you go dead centre with your vehicle, how much either side is it? 6.8. So would that be 3.4 to the right? Is that alright with you? Yeah. Okay. And how high is it? 4.4. And if I did the distance from I'm trying to think, 3.4 wide, 4.4. And what height's the tunnel again? 6.4. I suppose it would clearly fit in, wouldn't it?
Yeah.
But it'd take up both lanes, so you wouldn't advise it, would you? Yeah, that's fair enough. If this was a two-way tunnel, what precautions would be required for a wide vehicle to enter the tunnel?
Yeah. Someone either end the tunnel, make sure no one comes in while you're putting the...
Yeah, you'd have to make sure that nobody else comes in the opposite way, or that the tunnel's a one-way system. Is that alright? Yeah, that's... If you were to really get down to that, it's a very complicated question. If you were to try and calculate can it fit in without hitting the edges and stuff. I think they wanted a more basic answer, which is what we sort of gave them, okay? Now, what about 13, lads? This is 13, alright? So, what does it tell us? 3 parallel lines, yeah? What does that make this line here then? What's this line called?
There's 4 parallel lines.
4 parallel lines.
One on top is parallel.
One on top is parallel as well. What does that make this line? What's it called? It's a transversal. A transversal is a line that hits 2 or more parallel lines. Is that okay? Now, Are they equally spaced?
Yes.
So A to P is the same as P to R is the same as R to D. Find A to P. No bother. Divide 1.8 by 3. 0.6, 0.6 and 0.6, okay? XY. Interesting. Have an idea. We're going to do Protagonists Theorem. And with Protagonists Theorem, we're going to calculate the length of A to C. Everybody happy with A to C? And what we're going to do with our answer? We're going to divide our answer by 3. Okay? So, did anybody get A to C squared equals 2.4 squared plus 1.8 squared? And what you get when you put that in the calculator?
9.
Just 9 on the money.
Oh, 9 equals AC squared.
Yeah.
3 equals
AC squared equals 9 and AC equals 3. And if AC equals 3, XY is 1/3 of AC, so XY will equal 1. Anybody else do it that way?
No.
What? Yeah. Yeah.
It's
What? Did you chop it up into a 0.6 and a 0.8?
Yeah, I chopped up into 0.8 and then I just did how I said it.
Yeah, 0.8 and a 0.6, yeah. Alright, cool.
I got a different answer. I didn't get it equals.
I think you might have made it. What two? Did you use 0.8 twice?
I used I let AX equal 0.8.
So if this is the point, I don't know, a letter that's not in use, M. XM will be 0.8
I was using a triangle APX.
and A
I was using the
ABX.
APX.
APX. Yeah, same deal. That's 0.6 and that's 0.8.
Yeah.
And then when you do Pythagoras theorem, you get 1. Guaranteed. 0.6 squared plus 0.8 squared is definitely 1. I know that by heart. Alright. Now, RAXZ is a parallelogram. Happy days. So RAXZ.
You don't have
We gotta find Z. RA. Oh, it's down here, isn't it? Because yeah, see that line there? If I drag that to X, where does it end up? At Z, doesn't it? So is everybody happy? You can see my parallelogram now? There it is there on the left hand side. Alright. What else does it want from me? Calculate the area. What's the area of a parallelogram again, lads? Base by perpendicular height. Okay? So, what is the height of the blue one? 0.8. What is the base of the red one? 1.2. So it's 1.2 multiplied by? 0.8. And what do we get? 0.96?
Yeah.
Meters squared. Is that it? So we've done 9 and 13. Oh, why am I recording again? I have all these done. Ugh. 16. Alright. They're only allowed to use a meter stick, are they? And they want to make sure it's at a right angle?
Yeah.
Is that right? Okay. Now, I know it says only using a meter stick, alright? But for argument's sake, we're going to say we can get a cone or something like that and put it down on the line. Or you can just mark it with the studs on your boot or something like that, okay?
Yeah.
So imagine you take a point here like this, okay? Oof. You're going to need string as well. Alright, so here's what you do. You use your meter stick and for argument's sake, go out 3 meters. Okay? And put it here. Go out the other side 4 meters. Does anybody know why I'm using 3 and 4? The hypotenuse is going to be 5, isn't it?
Yeah.
Alright? And get a piece of string and nail it into the ground and make it really tight from here to here. Okay? And this can be X. Oh, sorry, I've already used too many x's. Call it L. L squared equals 3 squared plus 4 squared, and if it's truly a right angled triangle, L squared will equal 25 and L equals 5. So you measure that using your meter stick, and if it's 5 meters, it's 90-degree angle. If it's not 5 meters, then it's not 90-degree angle. Does that make sense? Charlie?
But if you could do it without string, if you did the hypotenuse measurement first and just made it less than a meter, like if you let the hypotenuse equal 1 meter and then just measure the other measurements.
Oh, gotcha. You could use 30, 40, you could use 30 centimeters, 40 centimeters, and then the length would have to be 50. And then you could do it without string. You could just do it with a marker and your meter stick. Yeah, that'd be a good way of doing it as well. So Charles' way is actually better, to be fair to him. Alright, you go to the corner, you measure 30 centimeters, you measure 40 centimeters, and then you know the hypotenuse will have to be 50. Do you know how I know that off by heart? How many 3, 4, 5 triangles have you done?
Lots.
And by the time you're in your leaving cert, you've done like close to hundreds of them. 3, 4, 5 is a guaranteed, and that means 50, 30, and 40 is a guaranteed right angle triangle as well. So that's how I'd organise it. Yep, that's perfect. 17 next, yeah?
Yep.
Okay. Back in the day, we used the calculator, didn't we? You can do 1.5 multiplied by 10, can't you? What's the other way of doing it? 1 hour, 30 minutes multiplied by 10. What distance did you get? 15?
Yep.
Okay, you got 15, and that means... Right, there to there is 15, isn't it?
Yep.
And now it wants the shortest distance, which we'll call x. Is that okay? 17 squared equals 15 squared plus x squared. Can somebody tell me what's 289? 225? X is 8, is it?
Yep.
X equals 8?
Yep.
Happy days. Alright. Now part 3. For how long in minutes is the ship within 10 kilometres of the lighthouse? This is actually an applied maths question we do in leaving cert, but yeah, it's a cool trick. You guys are going to need it. It's an advanced question, but look, we'll run with it. Alright? Imagine you're the ship, right? And this is the ship here, okay? How far away from the lighthouse am I currently?
17.
Okay. How far am I away now?
Dunno.
Somewhere between 8 and 17. Would you agree with that?
Yep.
And then when I reach here, how far away from the lighthouse am I?
30 feet.
Okay. So here. Can I just, for argument's sake, call that 10?
Yep.
Okay. Keep going. I'm 10 kilometres away. Oh, I'm 9 kilometres away. Now I'm 8 kilometres away. Now I'm
9. 10.
10. Everybody cool in a isosceles triangle? Okay. It's a cool question, to be fair to it. So something you guys will know. You're already going to be doing applied maths when you do leaving cert. So, right, here's what we're going to say. This is a distance of 8, isn't it?
Yep.
That's a distance of 10.
Yep.
Let's do Protagonists Theorem to figure out what is the yellow distance here, which we'll call x again. Okay. So what's a 10 squared equals?
6 squared from x squared.
100 take away 64.
36.
X equals?
6.
So it's 6 kilometers. It's 6 kilometers from 10 to 8, and then it's another 6 kilometers from 8 to 10, which is how many kilometers in total?
12.
It has to travel 12 kilometers in that range. So when it travels here, it's then within 10 kilometers, and then it travels 12 kilometers this way until it's back outside the 10 gap. Now it's 12 kilometers. How fast is he going?
10 kilometers now.
What's 12 divided by 10? 1.2.
Yeah.
And press the DMS button or the angle button, and what would it give you?
1 hour, 12 minutes.
1 hour 12 minutes. Who got that last night? It's a cool trick, isn't it?
Yeah.
Yeah. you get it next time, but it's a cool trick. Alright. Oh man. This was not a nice question, was it? A lot of writing, isn't there? Okay, so what do we reckon? Okay. Here's your map. Let's start at midday. Lighthouse doesn't move, does it? Ship. 31. What way does it go?
East.
Then 2 hours later it's 31. Sorry, that's west, isn't it?
Yeah.
East. Ship's there then later on, isn't it? And it's also 31, yeah? And the ship travelled along what line? Ship must have travelled along this pink line here. From here to here. Okay?
So
Now, what direction did the ship travel?
southeast.
Southeast. It's a 45-degree angle because it's a isosceles. And that's 90, the other two have to be 45. So that means it travelled southeast. Okay with that?
Yeah.
Alright. Now, find the distance travelled. Protagonists Theorem. X squared equals 31 squared plus
44.
before you got 44, it's is it 1922?
Yeah, but that doesn't give me 44.
Yeah.
Got 31 or 2.
31 or 2 or no 43.84 rounded up to 44 if you're rounding up, which you are to the nearest kilometre. So it's 43.84, but we were told by the question to round it up to 44 kilometres. Calculate the speed of the ship. How fast is the ship going? 44 kilometres in how many hours?
2 hours.
That's the rounded off answer though, isn't it?
Yeah.
So it's not actually going 22 kilometres an hour, but it's a rounded off answer. I'll find the point at which the ship was closest to the lighthouse. What do you reckon?
In the middle.
Dead centre, isn't it? Yep. So something like this, isn't it? What do I do with my 44 kilometres?
Half it.
Half it. And what do I get?
Right angle triangle.
22. That's at 90 degrees when you're at your closest. And this is 31, isn't it? And what distance am I looking for? Looking for that distance there, haven't I?
Yeah.
So how would I do that?
31 squared is equal to 22 squared plus our distance out of
31 squared equals
22 squared.
plus
D
D
squared.
squared.
31 squared, anybody?
1922.
19?
32. Oh, I think.
No, for 31 squared, it should be a 1.
Oh no, that's
961.
Yeah, no, that's what I got from the earlier.
961. 22 squared, 484, is it?
484.
Yeah, it's just memory. And take them away from each other. 477 equals d squared. Square root your answer.
3 root 53.
What?
3 root 53.
Jesus. And decimals.
21.84.
21.84. Anybody get that one now? D is 22, is it?
Doesn't ask for the nearest kilometre.
Oh, doesn't that, so 21.84?
Yeah.
Alright. So, we did that, and at what point was the ship closest to the lighthouse? Halfway during its motion. Alright, so that was done. Happy days. Alright.
Wait, sir.